talking about specifically a circle. All right, go ahead and draw a coordinate plane at the top of your notes. Anybody tell me where is 0 degrees? That would be where the point is. What about degrees if we're talking about the unit circle? Where is 0 degrees? Anybody know? Nobody knows where 0 degrees is?
On the circle.
Okay, where on the circle?
Line, outside.
Which line? Somebody come point to it. Maybe you can do better pointing. Come on up, Phil.
I don't know.
You don't know where 0 degrees? Y'all didn't review unit circle and geometry at all? Okay. Well, 0 degrees starts right here. Okay. So on the x-axis, on the right side of the circle. And then it goes in a counterclockwise motion. Okay? So if we're going counterclockwise, anybody know what this degrees is? 90. Very good. And it looks like a 90-degree angle, doesn't it? Then what do you think this one would be? 180. Very good. This one? 270. How'd you get that? Added what? Good. So from here to here is 90 degrees. From here to here is 90 degrees. You add 90 to 180, you'll get 270. Very good. And then when you add 90 to 270, you're going to get what? 360. So 0 and 360 are really in the same spot. They start and end at the same spot. And we're going to use this to create angle measures, to draw angle measures, okay? Alright, so the first one, it says draw an angle with a measure of 210 in standard position. And if you can break it up, using what we just learned, like breaking 210 up into 2 separate degrees, you can do it that way. So we know these 3 angle measures, right? 90, 180, 270, and 0. Let's take 90 from 210. What would we get? 210 minus 90. What'd you get? 120. So 90 and 120 would give us 210. And let's try 180 now. What's 210 minus 180? Okay. Maybe I should have given out a unit circle first. Alright, let's use 180 and 30. You could use either one. We know 180 is right here, correct? Any idea where 30 would be? 30 degrees past 180? How much is from 180 to 270? 90. So 30 compared to 90 is about 1/3 of it, right? So 270 would be maybe about right here, about 1/3 past 180. Everybody agree? And we don't have protractors, so this is really just estimating. So go ahead and draw your coordinate plane. And we always start from right here, from 0. Okay? And again, 210 is going to be 180 and then 1/3 of the way down. So we can go ahead and draw that angle. And then the only other thing we have to do in our picture is just make sure that we show that it started from 0. And that's how you show that. And then I don't care where you put 210 degrees, I'll just put it right here, 210 degrees. So that's all we're doing. We're just drawing 210, the angle. And again, go ahead and label this so that way you can start memorizing. This is what? 0 degrees or 360. This is what? 90. This is 180 and 270. Good. Let's go ahead and label that with all of them so we can get used to memorizing that. Yes, Jackson.
It like gave us 90 and 210. How did you get to 180 and 30?
What I did was I just used some of these angles, so I just subtracted 90 from 210. That way it'd be easier to draw. So I could say go to 90, then go 120 degrees past it. Well, that would be kind of difficult, like judging 120 degrees, right, past 90. That's why I used 180. We know where 180 is, and we know 30, like we said, is 1/3 of 90. So that would be easier to draw using these two angles. Does that make sense? Okay. All right, on the next one, this is negative 45 degrees, okay? Well, let's draw our X and Y coordinate first. And go ahead and label these 0 / 360, 90, 180, 270. Negative degrees just means it's going to go the opposite way. So this way the measures go counterclockwise. If it's negative, that means it starts from 0 and goes counterclockwise. Kind of like on a number line. When you go, if you're going negative, you go left from 0, correct? So on this one, we're going to go right from 0. And 45 degrees, what do we know about that compared to these angles? It's half of 90. Good. So we're going to start here and go halfway in between this, right? Because it's 90 degrees between these two angles, right? So we're going to go halfway, which is going to be about right here. And now instead of going this way, we're going to have to show that we went in the negative direction by starting at 0 and pointing this way and writing 45 degrees somewhere on there.
You did negative 45?
Yes, thank you. And you can write it in between here, right here, wherever you would like, as long as it's close to this angle.
You did that because counterclockwise.
This way is clockwise, right? It's okay. Alright, next one, 225. Let's think about how we could break this up. 225 is close to which degree?
180.
Closer to which one? We can do 180. So how would we figure out what other angle we would need besides 180? Got to subtract, right? So what's 225 minus 180? 45 degrees. Good. So we can use 180 and 45. 180 is right here, and we just have to go 45 degrees past 180, so that's going to be where? What do we know about 45? It's half of 90, right? And so from 180 to 270 is how many degrees? From 180 to 270? 90. So we would go halfway past 180, right? So that would be right here. Each section is 90 degrees. Everybody notice that? Alright, and we would show we went from 0 and that this is 225 degrees. Who had pre-AP geometry last year? Did y'all go over the unit circle?
I don't remember.
Okay. No? Okay, I'll print one off and give it to y'all tomorrow. Alright, next one, negative 60. We can go ahead and draw our angles or our degrees that we know. Alright, we're starting from 0 and going which direction? Counterclockwise or clockwise? Clockwise, because it's negative. And between 360 and 270, it's what degrees? 90. Okay, so 60 is going to be a little bit more than 45, correct? Closer to 90. So it's going to be right about here. Again, we don't have protractors, so as long as it's close to that angle and not something crazy like way over here, you will get it correct on your test. Alright, show that we came from 0 and went clockwise and that this is negative 60 degrees. Alright, questions about these? Alright, flip it over. I want you to try one more of these on your own. I should have let you do 4 on your own. Go ahead and try it over here on the front page.
Can you get back to the last one?
Yes, I can. Give me 1 second.
Okay.
Alright, I want you to draw, let's do 135 degrees. So go ahead and sketch that on your paper, 135 degrees, and then I'll come around and check in just a second.
Just anyway.
Yeah, you can draw it on your front page, somewhere on the side.
sure this goes all the way to that angle.
Anybody else need more time? Or want me to take theirs? Alright, so everybody's good with drawing angles, I feel like. Should have looked like this. What two angles did y'all use to draw it? 90 and 90 plus what equals 35? 90 plus what equals 135? 45, good. So the way I did it, I don't know how y'all did it, but I went to 90 and then went halfway past it. Is that what y'all did? Yes? Any questions? Alright, flip it over. So the next thing we're going to talk about are coterminal angles. And two or more angles in standard position. So that just means starting from 0 like we just did. With the same terminal side are called coterminal angles. For example, angle measures 60, 420, and negative 300 are coterminal. And you can see this by drawing each in standard position. Yes. Oh, I thought you raised your hand. Go ahead and draw a coordinate plane. And we're going to draw all three of these angles, 60, 420, and negative 300. So you can see that they're the same thing. Again, this is 0 to 360. This one's 90, 180, 270. Alright, let's first draw 60 degrees, this first angle. Somebody come point to me on the board where that angle would be. Where to draw my line. Come point. Come on up. Just point to it on that.
A little past halfway.
Show me. Go point to it. It's your world.
Right in there.
Okay, good. So this is 60 degrees. Alright, what about 420? How could we do that? What do you notice about 420? It's bigger than 360, right? How much bigger? So 420 minus 360 is what? 60. So all this means is the angle does a full circle and comes back to 60 degrees. So you wouldn't have to change your line. You just have to change this part. So it started from 0, went where? All the way around and back to 60 degrees. Good. And these are coterminal because they're the same angle, right? Or the same position. Different angles but the same position. And now what about negative 300? How do you know?
Because you're going backwards.
You're going backwards.
Or clockwise.
Yes, you're starting from here and going 300 degrees, right? This way. And that's going to end up being what?
60.
Good, because 360 minus 300 is what? 60. So we're starting from here going around, but you're still being in the same position. This is why these are coterminal. They're different degrees, but they're the same position. Does that make sense? Alright. And an easy way to find these coterminal angles, what is 60 plus 360? Good. 360 plus, or 60 plus 360 is 420. Now do 60 minus 360. That's going to give us what? Negative 300. So, you just figured out how to find coterminal angles. You just do what? What did we just do? We added 360, right, to get this one, and subtracted 360 to get this one. That's how you find coterminal angles. So for 210, it says find a positive measure and an angle with a negative measure that are coterminal with 210. So what do you think we're going to do? Somebody said it. Add 360 and subtract 360. So tell me what the positive coterminal angle would be. 500 and what? 70. And what would the negative be? Negative 150 degrees? Everybody get that? Very good. That's it.
You don't gotta make a graph. Oh, you don't make a graph?
Nope. We're just trying to find the angles. We're not trying to graph them. All right, so tell me the positive coterminal angle for negative 200 degrees. Anybody?
160.
And then tell me the negative.
Negative 560.
Very good. All right, last one. Tell me the positive
370.
and negative.
45. Negative 345.
Everybody get that? 15 minus 360.
Negative 345.
Good. Any questions about finding coterminal angles? Pretty easy.
Or we just go.
You just do 15 plus 360. I just put a plus. Makes 375. 15 minus 360, negative 345. I just didn't write it out. All right, flip it over. So now we are going to go from radians to degrees. You remember that button in your calculator that had radians degrees? Remember we had to swap it to degrees. Don't swap it, but I was just letting you know that this is where this comes into play. All right, radians just means that it's going to have some number with pi on top over some degrees. Okay, and degrees, we know what that looks like 30 degrees. Now it's our job to put it in radians. So if it's in degrees already, what you're going to do is write 30 pi, and I got the 30 from this degrees, over 180. And the reason I do that is because pi is 180 on the unit circle. And apparently y'all didn't know that, but now you do. You can write this at the top. Pi equals 180 degrees. They're the exact same thing. So the reason we multiply the top by pi and the bottom by 180 is we don't want to change the degrees. This is the same as like 30 times 180 over 180. So it's still 30 degrees, right? Now we just have to simplify 30 in 180. So what is the number that can go into 30 and 180? The biggest number you can think of.
Just 30.
30? How many times can 30 go into 180? And 30 go into 30? Good. So I wouldn't have to put 30 on top. I could just put pi. This is 30 degrees in radians. And the easiest way to check this, since pi and 180 are the same thing, you just type in 180 divided by 6 in your calculator, and that should give you what? 30 degrees. So we know we've done it correctly. That's how you check it. Questions about that? All right, tell me how to first set up 120 degrees, how to write it in radians. Good. All right, what's the number that can go into 120 and 180, the biggest number you can think of? 60? Okay, how many times can 60 go into 120? So 2 pi over, how many times can 60 go into 180? Good. And now to check it, you can just do 2 times pi. That'll give us what? 360. And now divide it by 3. Tell me what you get. 120. So we know we've done it correctly. Questions about that part? Yes. Yes, it does. All right, next one, do on your own. And then tell me whenever you get the answer. Anybody need more time? What you got? Anybody? Pi Good. And you can put the negative on top or on bottom, it doesn't matter. Negative pi over 4 is correct. Do I need to work this out?
Yes.
Okay. So we would start it off by doing negative 45 pi over what? 180. And then what's the number that can go into 45 and 180? 45, good. So 45 goes into negative 45, negative 1 times, right? And how many times does 45 go into 180? 4. And then to check it, you just do negative, what? 180 divided by 4. You should get negative 45. Let me see.
So instead of putting pi, we need to put it, what's pi percent? Negative 185.
Alright, so now we're going to do the opposite. We're going to have them in radians and put them in degrees. Any idea how we're going to do this? Good. You just do 5 times 180, because pi is the same thing as 180, and then divide it by 4. Tell me what you get. What now?
45.
Good. 225 degrees. And to check this, let me show you how you could do this a different way. Let me fix my mode. Never mind. You can just check it by doing 5 times 180 divided by 4. Make sure it's the same. Alright, go ahead and do 5 and 6 on your own, and I'll call on 2 people to tell me the correct answer. Alright, anybody need more time? What's the answer to number 5? Anybody? Negative 67.5 degrees. Everybody agree? Yes. What about number 6? Good. Everybody's good with converting degrees to radians? Alright, flip it over. So now we are going to talk about arc length. So for a circle with radius r and central angle theta in radians, the arc length, and we're going to let S stand for arc length, equals the product of r and theta. Alright, so the first thing we're going to see is an example of a monster truck steering wheel. And the steering wheel on a monster truck has a radius of 11 inches, so let's write r equals 11, correct? How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? Okay, so a rotation you can think of is what? A circle, which is 360 degrees. And this says it makes 4/5 of 360, right? 4/5 of a rotation. Does that make sense? Okay, so that would be our theta, right? 4/5 of 360. Says find the central angle in radians. Okay, so we're going to have to first go ahead and multiply this. 4 over 5 times 360 over 1. And let's cross simplify first. What can 5 and 360 both, what's a number that can go into both 5 and 360? So this would be 1. How many times can 5 go into 360? How many?
72.
Okay, so now we can multiply what? 4 and 72. That's going to make what? 280 degrees, right? But it says we need to put this in radians. 288? Okay. Thank you. We need to put this in radians. Right now it's in degrees. How do we do that? We do 288 over, good. Now, what is a number that can go into 288 and 180? I don't have a calculator up here, so y'all are going to have to let me know.
Well,
Let's start with a bigger number. Can 12 go into 288?
yeah.
How many times?
24.
Alright, can 12 go into 180?
Yes.
How many times?
15.
Alright, can we simplify it more? Yes, we can. What goes into both of them? Alright, how many times up top? And on bottom? Good. Go ahead and check that this is 288 degrees. How would I check it? 8 times 180 divided by 5. Does it equal 288? Good. So now it says use the radius, which we found up here, and the central angle, which we found right here, to find the arc length. And the arc length, again, it stands for S. So we have S equals R, which is 11, and I'm going to write it as a fraction, times theta. And theta is what? 8.
5.
Good, over 5. That's what we just found. Was the angle measure. And now we can multiply. So S equals what? Can we multiply 11 and 8 pi? Could we multiply X and Y? Are you sure? We can multiply them, right? We can't add them or subtract them because they're not like terms. Same thing here. Just because they're not like terms, we're still multiplying, not adding and subtracting, so we can multiply them. It would make what? 88 pi over 5. Good. Make sure at this point, go ahead and make sure that your calculator is in degrees, if it's not already.
How do you check?
What kind of calculator do you have? TI 83? 84? Go to mode, that button at the top, and make sure it's on degrees.
It is.
Okay. And now, what you need to do is type in 88 pi, and if you're using a TI 83 or 84, the pi button's in yellow right above the raising to a power, so you'll have to hit second and then that button. 88 pi, hit enter, and now divide it by 5. And so our answer is 55 point, let's round to the nearest 100, 29. And let's see, did they tell us if this is feet or not?
Inches.
Where do you see that? There we go. Very good. Any questions on that one?
So whenever we're finding the arc length, we don't have to become pi over 180.
No, we do not. Alright, moving on to the next one. A circle has a diameter of 9 centimeters. What do we need, though? The radius. So what would the radius be? 4.5. We can go ahead and write that down. Find the arc length if the central angle is 60 degrees. What do we need to do with that? Over 180. Very good. And did y'all know we can cancel out those zeros?
Yes.
Yes. So what goes into 6 and 18?
6.
How many times up top?
1.
Over 3. Good. Make sure that pi, or 180 divided by 3, is 60. It should be. And now we can go ahead and find the arc length. And so the arc length is r times theta. Let's go ahead and leave the radius instead of a decimal as a fraction. That'll be easier to multiply. So what is the radius as a fraction? 9 over 2. Good. We had to divide that by 2, right? Times what? Pi over 3. We can cross simplify by doing what? Making this a and this a. And so we would have 3 pi over 2. And now go ahead and find out what that would be. S equals, good, 4.71. Any questions on that one?
Oh, you got the very last
Oh, thank you. Alright, try number 3 on your own.
Can you explain how you got the like just the mean? Can you do like just the last part?
The 3 pi over 2? Or this part. You just type in your calculator 3 times pi and then divide by 2.
I'm just looking
Alright, try 3 on your own.